number of lessons ago, what we looked at was the solution of quadratic inequalities from an algebraic point of view. If you remember, we looked at compound sentences that involved the use of the words and or. And at that time, I said that later on we're going to do the same idea, but from a geometric point of view. And in fact, that's exactly what we're going to do in today's lesson. In order to do so, let's look at an example. And suppose we were to take a function such as y is equal to x squared minus 6x plus 8. All right? And this is what we've been doing in yesterday's lesson, certainly. And you look at this and you complete the square. So we have x squared minus 6x. And then what number would you like to add here, Doug?
9.
Plus 9. And now to get back to what you started with, then we would like to, Doug, subtract 1, and then we have this in the pattern of x minus 3, the quantity squared minus 1. And you look at that and you say, well, it's very easy for me to make its graph. So let's turn over here to a coordinate axis. And I've already made this graph as you see it right here. Now, the question that we would like to ask ourselves is the following. Well, let me repeat this. Y is equal to, here we have x squared minus 6x plus 8. Now, the question that we would like to ask ourselves is, what values do we have on our graph for which y is greater than or equal to 0? And just looking at our picture here, you say, well, where y is greater than or equal to 0 is where we are above the x-axis. Is that right? On the x-axis and above it. So you say, oh yes, this number, certainly this height is positive, non-negative, this one. In fact, all of these numbers will give us values which are greater than or equal to 0. Is that right? Now, this is a name for y, and we have another name for y, namely x squared minus 6x plus 8. And now the question is, what values for this function are greater than or equal to 0? And sure enough, they're the same values which are above the x-axis. Everyone agrees with that? All right. Now, crucial question is, for what values of x will make this true? And looking at our picture again, what values along our x-axis here will make the value of the function greater than or equal to 0? And just looking at the picture, what values of x will do that? Phil?
Where x is less than 2 or x is greater than 2.
All right. Less than or equal to 2. Is that right? We do want to include the endpoint. So those values of x which are less than or equal to 2 or greater than or equal to 4. Is that right? Will then make this sentence true. So in fact, let's write that down as our solution set. We're interested in all values of x which will make this sentence true. Thinking of this as a function, all right, as our second element of our ordered pair, there it is, x squared minus 6x plus 8. Those are the values which are above the x-axis. The values of x which will make that function true, you then say are the set of all x's such that what? X is less than or equal to 2, or x is greater than or equal to 4, and that then is the solution set to this sentence right here. Notice how we got there. We thought of it in terms of the corresponding function, and then in fact we then found those values of x which will make it true. Let's look at a second example. Let me come back here where we can write on the board, in which we have, well, let's take negative 2x squared minus x plus 6 is greater than 0. Now, in this case, let's go right to the sentence which we would like to solve. Looking at it, what I'd like to do is to think about the corresponding equality. All right? Now, this is where the value of the function crosses what? As soon as we say it's equal to 0, this is where the function, the corresponding function that we have, and whose graph is going to do what? It's going to, Malcolm? It's going to cross the x-axis. And it seems as if those points are quite critical, aren't they, as far as deciding which numbers will be above the x-axis or indeed below the x-axis. Well, let's look at this, and you say, well, I possibly can factor this expression on the left side. We have there negative 2x times an x, say, is a negative 2x squared. Not much else we can do there. Let's look at this number 6. And does anyone see any combination here which is then going to be able to factor this, huh?
+2 on the right.
A +2 on the right is the, and I think it's a positive 3 on the left factor. Is that right? Because then we'll have what? A negative 4x plus 3x is a negative 1x, and 3 times 2 is 6. Therefore, a negative 2x plus 3 is equal to 0, or x plus what, 2 is 0. Therefore, x here must be equal to what number? But positive 3/2, or x then is equal to what? A negative 2. Now, this is, here we have some function in which we want to show that this value is greater than or equal to 0. All right? We looked then at the corresponding equality, found out where it crossed the x-axis. Let's now turn to our coordinate axes and see what this graph is going to look like. And here we have a picture in which we have, well, let's talk simply about greater than 0, okay, rather than greater than or equal to, just for variety. And now notice, here is a function in which we want to have all values of this function to be greater than 0. And looking at our picture, we know that the curve is going to be concave down because of this negative sign. And now, where on this picture is the function greater than 0? And you say, well, any place where it's above the x-axis, and that's going to be right in here, certainly. Now, the question is, for what values of x will make that sentence true? And Doug?
Such as x is greater than -2.
All right, let's, on our graph, certainly then, well, let's use our open circle idea. It's certainly then going to be what? Inside, right, of, and less than 3/2. So we are interested in all values of x right in here, in that interval. Is that right? And now just writing that as a solution set, it's a set of all x's such that x then is going to be less than, what, 3/2 and greater than -2, and we're done. Now notice that all we needed to do was to find those points where the graph crossed the x-axis. Is that right? Those are our critical points, so to speak. And without actually making a graph, without actually making a graph of our function, we know that it's going to be concave down, and all we need to know is to find out where it crosses the x-axis, and since it's concave down and does cross the x-axis, then certainly you know that it must be inside. Is that right? Let's look at another example, if we can, and see what's going to happen with that. Well, let's see now. Let's work over here on the board for a few minutes, in which we have x squared minus 4x minus 6 is less than or equal to 0. Here now is our inequality, and let's look at the corresponding function where the graph is going to cross the x-axis, which is then going to be equal to 0. I think if you look at that for just a second or two, you say to yourself, what, I don't think it can be factored. Is that right? So immediately you want to go to the, what, to the quadratic formula. All right, then x then is equal to what? The opposite of b, which is what? 4 plus or minus the square root of this number squared, -4 squared, negative what? 4 times 1 times -6, is that right? All divided by 2 times 1. All right, now let's clean this up. Then we have 4 plus or minus the square root of. This is what number? 16. That's a -4 times a -6 is plus 24 all over 2. This then is 4 plus or minus the square root of 40 all over 2, and that then is 4 plus or minus, what, 2, the square root of 10 all over 2, which is 2 plus or minus the square root of 10. Now, without looking at our graph, we're now concerned with this inequality, this quadratic sentence for which it is going to be less than or equal to 0. Notice now the curve is going to be what? Concave up or down? Up. And the fact that it's going to be concave up, these are our critical points of 2 plus the square root of 10 and 2 minus the square root of 10. We're interested in all values such as less than or equal to 0. So do you think it's going to be inside of some interval or outside of some interval? And just by thinking about the graph without actually making it, what's your conclusion, Tom? It's going to be inside of some interval. Well, let's look at a graph. And in fact, here is a picture of this function. We're concerned with x squared minus 4x minus 6, which is less than or equal to 0. Since it is concave up, and since we want those values of the function for which it is below the x-axis, I think then everyone will conclude that it must include what values of x, but everything which is what? On this critical point, and this critical point, and everything where? Inside. Okay. And And now if we were to write that as a solution set, it's a set of all x's such that, and here we have what? X is less than or equal to, we have this number of 2 plus root 10, and that then is also greater than or equal to 2 minus root 10, and that then is the solution set of this sentence. All right? Well, let's then look at a last example. Suppose we were to take a cubic. Even though the name of this lesson has to do with a quadratic, let's look at something such as x cubed minus 4x is less than 0. Now, again, the corresponding function for which it is set equal to 0 is going to look like this, in which you say to yourself, oh yes, I may factor out that number of x, and then there's a difference of squares, in which we have this sentence. Therefore, what numbers are x equal to? X then is equal to what? 0, or x is equal to, here we have a negative 2, or x is equal to 2. Now, these are our critical points. That's where the graph is going to cross what? It's going to cross the x-axis. We're interested in those values for which the value of the function is going to be less than 0. Now, since it's a cubic, all right, let's then turn to our graph and see what this cubic looks like. Here we have a graph of this cubic, and I think you'll agree for values of x which are, say, negative 100 cubed is going to be way down here on our graph, isn't that right? So I think you'll agree that our graph will have to come up and then do something and then continue on up as we move from left to right. Does everyone agree with that? Okay? And in fact, this is what the graph is going to look like. Now, let's look at this graph and our function. We're interested in those values for which x cubed minus 4x is less than 0. That's where the value of the function is below the x-axis. All right, what numbers x will do that for us? And just looking at our picture here, can anyone just pick out those values of x which will make the value of the function less than 0? And Tim?
X less than negative 2.
All right, x is less than negative 2. Let's do this in our graph first, in which there then is a heavy line with an arrow indicating it goes on forever this way.
And x is greater than 0.
Greater than 0, and less than 2, and everything inside of this interval. You remember when we did in fact, we didn't even dare do a cubic from an algebraic point of view because the algebra and the logic involved got a little bit messy. But right here, it falls out very easily, and we can write our solution set as what? The set of all x's such that, and here we can say what? X is less than negative 2. What word do I want to use now? Or, and now let's put this number inside of this interval. X is where? Between, it's going to be less than 2 and greater than 0, and we're done. There's the solution set of this sentence by means of this graph. So let me give you your homework assignment, which you'll have an opportunity to try some of these for yourself. This will be a